chi-square test. And when we're doing chi-square, this is used when I have two variables that are either nominal or ordinal. So if you recall, a t-test and an ANOVA and a regression are going to require data that is numeric in nature. So it's going to require that interval or ratio level data. Correlations can be done with nominal or ordinal variables, and so can chi-squared. Chi-square is mainly happening when you're looking for an observed number of occurrences. So maybe you're doing an observation in a classroom and you're looking at the number of times a particular student disrupts the class. So with that, we want the number of observed incidents to be more than 5, otherwise we can't run the chi-square. So the assumptions you're making when you're running chi-square is that your data is going to be nominal or ordinal, that the number of occurrences of this thing is going to be 5 or more, and then of course that our data is independent. So we're going to take a look at an example of a chi-square, and our research question is going to be, do students in fast and regular academic track differ on whether they have mainly high or low math grades? If so, how strong is the relationship between academic track and high or low math grades? So you'll notice the way this question is worded is I'm not necessarily observing a class, right? I'm observing the number of high or low grades for fast track and academic track. Based on the fact that my data set is so large, I'm going to assume that the high and the low grades occur more than 5 times. So that is going to be an assumption that I would use. So let's see how we would run this analysis. When we run this analysis, we're going to be using a different menu than we've typically used before. So we are going to go into the crosstabs menu, which is going to be found by going to Analyze, Descriptive Statistics, and Crosstabs. Now, crosstabs doesn't really resonate with chi-square, so this is something you would want to make sure that you are paying attention to where to find. You put it on a sticky, or you come back to this video to figure out where it goes. So because our research question is looking at the occurrence of math grades is going to go into the rows box. And we want to make sure we're using math grades and not a different variable that's similar to it. So the thing you're observing goes into the rows. We're going to put academic track into the columns because that's how we're essentially grouping students to look at this occurrence. Now, technically, there's some wiggle room in how you define these, but as always, I like to give you a consistent way to look at things. So this is Dr. Robinson's spin on where things should go by row and by column so that we just have a convention to follow. Now you're going to click on Statistics, and you want to be sure to check off chi-square and pi and Kramer's V. So these 2 boxes need to be checked off. Then I'm going to click Continue. Once I'm back here, I'm going to click on Cells. So there's a lot of background work that's happening here. When I click on Cells, I want to make sure I have observed and expected checked. That's not typically going to happen on its own. And then I also want to make sure I've got counts and column checked under percentages. So I need to make sure I've checked off column here, and that's what triggers the count to happen. Once I've got this checked off, I want to make sure that I have the correct information in the choice of what the non-weighted pieces are. So that would be my round cell counts. I don't want to use decimals or anything else. I'm going to click Continue, and then I'm going to click OK to actually run the chi-square. And you're going to notice you get a lot of information when you run this. We get multiple tables. The case processing summary table is just going to summarize the fact that we have 75 data points. I have nothing missing. So this shouldn't be something we really spend a lot of time with unless you're trying to figure out, did I mis-enter something? Did I skip a cell? Here I have my math grades and academic track cross tabulation. So in this area, what's interesting is we have a count and we have an expected count. So what this means is I had 24 students in fast track that scored less than an A or a B. I would have expected, based on my chi-square analysis, to have seen 19.9. I had 10 with mostly A to Bs in my fast track, and I would have expected to see 14. Then regular track had 20 with less than an A or a B, and I would have expected to see 24. I had 21, and I would have expected to see 16.9. Now, like we've seen with ANOVAs and t-tests, the question is, yes, those values are different, but are they significantly different? And that's kind of the interesting piece of this is the expected counts are telling me, based on my analysis, what should I see? But just because I'm 5 less, roughly, that doesn't mean that it's significant. So the way you're going to tell if it's significant is you're going to come down into the chi-square test, and we're always going to look at the Pearson chi-square top row right here. This is going to be just like our usual p-value, and it's going to tell us, is there a statistically significant difference here with what's going on with my expected and my counts, which is going to answer my research question. If you remember my research question here on, do students and academic tracks differ on whether they have mainly high or low math grades? So if so, how strong is the relationship? So I'm answering if they differ. If it is not significant, they don't differ. If it is significant, they do differ. So because this p-value is greater than 0.05, it's going to be not significant. So because it's not significant, we full stop. We don't continue on with our chi-square analysis because it's not significant. Now, the question becomes, what would I have done if it was significant? If it was significant, I would be looking at, okay, now I know that it's significant. What is the strength of the relationship? And that comes into play from the symmetric measures table. So if you find that it is significant, then you would continue to look at this last table here, and you would look at the value of the statistics. So the value column should be relatively close to 0. If the relationship or effect size is large, it would be around 0.5, either positive or negative or more. And so we're oscillating between, kind of like we did before. Large would be 0.5. Anything less than that is going to be pretty small. Something like 0.25 would be kind of my guideline. That would be a small effect size. And then 0.75 would be larger than normal. Just like we've seen with some of those other effect sizes, they kind of go in increments of 0.25. So the results write-up for this, guys, is beautiful. You're going to say, I was looking to investigate you're going to restate your research question. So I was looking to investigate if students in fast and regular academic tracks differ on whether they have mainly high or low math grades. You would italicize academic track and math grades. You would say, I conducted a chi-square statistic test in order to make this determination. My assumptions were met because my data is nominal or ordinal, and it is independent. Then you would say, table, whatever number you're going to designate your table that shows the significance. So remember, that table is called the chi-square tests. So the chi-square test table indicates that there is not a statistically significant difference on whether they have high or low math scores for academic track. And you're going to report that the chi-square is 3.65, my degrees of freedom is 1, I have n equals 75, and I have p equals 0.056. So fast track students are not more likely than expected by chance to have a low or high math grade than regular track students. And I'm going to email out that results section right up so you can see exactly what I'm looking at when I say that. I just wanted to avoid a second video for results because this is a quick test.